For centuries, people assumed that older machines were simple. Basic mechanisms from a world that didn't yet understand precision engineering. But the deeper historians dig into the workshops, shipyards, and factories of the 17th to 19th centuries, the more one truth becomes impossible to ignore. Some early machines were so flawlessly built, so perfectly tuned, that modern engineers still struggle to recreate them, even with CNC tools, computers, and modern metallurgy. Today, we uncover 6 devices from the early mechanical age that technology can describe on paper, but still cannot truly rebuild. Number 1, the 18th century marine chronometer. Before satellites, before global navigation systems, and even before accurate world maps, the ability to measure time precisely at sea determined whether ships lived or died. A handful of craftsmen built marine chronometers so accurate that some drifted only a few seconds over an entire century. Their gearing, their escapements, their temperature compensation systems were hand-adjusted using experience, not formulas. Modern reproductions, even with high-end machining, cannot match the long-term stability of the originals. To this day, the exact touch those makers had is something engineering can't simulate. Number 2, the Breguet overcoil balance spring. In the early 1800s, Abraham Louis Breguet created a spiral spring that balanced force so perfectly that it set the standard for mechanical timekeeping. But here's the mystery. The forging and tempering process that gave the overcoil its perfect elasticity has never been fully replicated. Modern versions come close, but micro-variations still affect stability. The original springs had a level of consistency that modern metallurgists still can't explain. Number 3, the atmospheric railway pump system. In the mid-19th century, engineers built a railway powered not by engines, but by vacuum pressure. A massive pipe ran beneath the tracks, sealed by a leather and wax mixture. When the pumping station activated, a vacuum pulled the train forward, silently. Here's the impossible part. Modern attempts to recreate the seal fail within hours. They dry out, crack, or collapse. Victorian-era seals lasted weeks. Whatever mixture they used, whatever they added to the leather, remains one of industrial history's most persistent mysteries. Number 4, the Japanese Sashukitai laminated steel. Across the 15th to 19th centuries, Japanese smiths created blade lamination structures so complex that even electron microscopes struggle to categorize the layers. Some portions are exceptionally hard, some unbelievably flexible, and the transitions between them appear almost mathematically perfect. Modern recreations crack, warp, or refuse to bond correctly. The original craftsmen combined heat cycles, quenching patterns, and folding sequences that modern metallurgists cannot replicate with full accuracy. It wasn't just blacksmithing. It was a lost science of materials. Number 5, the Philadelphia Waterworks hydraulic impeller. In the 1800s, one of the earliest municipal water systems in America was powered by a massive wooden andiron impeller. Engineers today can model its behavior, but full reconstructions never match the original's efficiency. The blade curvature was so precisely shaped by hand, the spacing so carefully tuned, that water flowed through it with industrial-level smoothness. Modern replicas, even with perfect measurements, produce turbulence the original never did. Number 6, the Jacquard loom punch mechanism. Often called the ancestor of computer programming, this loom used punch cards to control patterns. But the true genius wasn't the cards. It was the machine itself. Early Jacquard mechanisms ran with almost no friction. Pins, forks, shuttles, all moving in synchrony, as if the entire loom were a single living mechanism. Today, CNC-made replicas introduce microfriction and timing drift. Even polished steel parts develop resistance that the original machines simply didn't have. Historians believe the originals were polished by hand, to tolerances modern factories do not attempt. Because such work is slow, expensive, and relies on a kind of craftsmanship that barely exists anymore. When we look at these 6 devices together, a pattern becomes clear. These weren't primitive attempts at modern engineering. They were masterpieces, built by craftsmen who shaped metal by sound, adjusted tolerances by instinct, and corrected vibration by feel. Machines we can measure. Machines we can model. Machines we can describe. But machines we cannot fully rebuild. Because technology doesn't always move forward. Sometimes it peaks in the hands of a small group of masters, and then disappears. And some of the most impressive machines ever created aren't from the ancient world, but from the early age of industry. A time when engineering wasn't just science, but an art. And their secrets are still waiting to be rediscovered.